Finding the cross product using the traditional method. So here we're going to find the cross product of two vectors u and v. So we'll write u cross v. And you can think of the traditional method as simply using a multiplicative distribution. So just doing your usual distribution law for multiplication. So here we have our 3i times our 2i, which gives 6i cross I. We have our 3i times our 5j, which gives us a plus 15i cross j. Continue distributing the 3i. So 3i times 3k is 9i cross k. And now we'll distribute our middle term, the negative 2j, and distribute that to the 2y, which gives us now a negative 4j cross j. Sorry, j cross I. And we distribute it now to the 5j, which gives us negative 10j cross j. Distributing it to the 3k gives us negative 6j cross k. Now let's distribute our just k. So k to our 2i gives us 2 times k cross I. Then our k to our 5j gives us 5k cross j. And our k to our 3k, which gives us positive 3k cross k. Now, to simplify this, I like to think of this kind of circular counterclockwise motion. So if we move counterclockwise, I cross j, we kind of continue to move counterclockwise. That produces the k. Continuing like this, we have j cross k gives us the I, moving that counterclockwise direction. Then k cross I gives j. So you kind of go in a loop. And then knowing that the cross product is anti-commutative is what they call it. Meaning if I reverse the order, all that really happens is I get the negative version. So here if I have j cross I going clockwise, it'll give me negative k. Or k cross j will give me negative I. Or I cross k will give me negative j. And so on. Then another thing to note is that whenever you cross product the same vector, you will get 0. And that's because they are parallel to each other. You can think about that more with the definition of the cross product. So now we could simplify. So we have 15 I cross j, which gives us a k, plus 9, and again we see I cross k, which gives us negative j. Then we have our negative 4, j cross I, which gives us negative k. We have our negative 6, j cross k, which gives an I. And we have 2, k cross I, which gives us a j. And then we have our 5, k cross j, which gives a negative I. Again, simplifying these, taking our minus signs out front. Combining things where we can, let's see. We have negative 6i minus 5i. So those are our i's. Let's look at our j's. For our j's, we have negative 9j and positive 2j. Now let's look at our k's. Let's cross these out just to keep track. We have 15k. And a minus 4k gives us positive 4k. And finally, simplifying, we get negative 11i minus 7j plus 19k. And that's our final cross product of u and v. Now let's take a look at what this actually means. What does this look like? So, using GeoGebra, I could plot u and v. And so you can see the labels are there. They're kind of rough. I have u and v. There's u that's kind of tilted a little more up, and v on the bottom. And this is w, which is what I'm calling the cross product between u and v. And we see that it's perpendicular to both u and v. And that's, in essence, what the cross product gives you.